Alright, cool. I think we are live. Alright, so I want to talk today about a little bit of string processing, in particular how to deal with this business of getting an H, an L, or a C, which is pretty straightforward once you know how to do it, but I want to sort of have a larger conversation about fgets and about strings in C. And then I want to talk about Makefiles, and then go back to GDB, and then we'll branch on from there. So any questions before we start all of that?
I also have a question. I was working on PA3, and I was trying to figure out how to do a log-based do function to calculate the amount of guesses there. Can you show me how to do that?
Sure.
You can use main.h. Yeah, I use main.h, but it said that like log-based do didn't exist or something like that, so I was wondering how to do it.
So there's a cool formula here. So log takes the natural log. So log base 2 is just the natural log of x over the natural log of 2. So you basically just scale by this constant 1 over log 2.
If it's saying it didn't exist, because there's also a log2 function in math.h, you're probably compiling without the -ln.
Yeah, so let's look at a sample code, which I just happened to have whipped up this morning. So here's a test program that asked me for a number x, does an fgets, does an scanf with a %lf to read in a floating point, prints that out, and then here's where I calculate the log base 2. So if I've got a real number x, a double, I can do log of x over log of 2. So GCC, if you just compile it like this, you'll get this warning saying undefined reference to log. So put a -lm at the end of your GCC line. And also in the beginning, make sure you include math.h. And then once you do that, if you do log divided by log 2, you get the log base 2. So 1,000, the log is approximately 10. And 64 should be 6, because 2 to the 6th is 64, and so on. So just do something like that. Log x over log 2. Does that make sense? All right, let's see. Go ahead and send me an attendance note, please. And any other questions?
You can go over the selection algorithm real quick.
The what algorithm?
The making a yes algorithm was. I was a little confused by the wording on the assignment.
Let's see, which part? Let me pull up the assignment here.
Let me scroll down to it. Yeah, the algorithm part. So I got my program mostly working, but I was only using low plus high divided by 2 to find the numbers. And
Okay.
I ended up not being able to guess the last number. Like if you made a search between 50 and 100, it would always go up to 99 and then say that was the seventh guess or the last guess, right?
Mm-hmm.
Not including 100, but that was the range.
So what were low and high in that case?
Low and high was 50 and 100.
No, I mean when it got down to 99, what were the values of low and high?
I haven't checked that yet.
Okay, so that would be one thing to check. But basically, you know, let's play the game from 1 to 10. So low equals 1, high equals 10. And let's suppose the person guessed the number 10, right? So guess will be halfway in between 1 plus 10, that'll be 5. We say 5 is too low, so low changes to 6. Guess will be halfway between 6 and 10, that'll be 8. We'll say 8 is too low, so low will change to 9. It'll guess halfway between 9 and 10, that'll be 9. We'll say 9 is too low, this will change low to 10. Now it'll say my guess is halfway between 10 and 10, which is 10. But you gotta be doing that plus 1 or minus 1 on the guess. If you just change high to guess or low to guess, then you may not get, to the actual number. So if the guess is too high, you gotta change high to guess minus 1. If it's too low, you gotta change low to guess plus 1. And I'm guessing, no pun intended, that might be what's missing.
Yeah, I would just set the guess to lower the guess.
Oh, okay. Yeah, so that will get stuck. Like if the guess is 9, and we say that's too low, if we just change low to guess, then we'll just be stuck at 9 and 10. So yeah, do that plus 1, minus 1. And then just to finish this out, right, if our guess is 10, and the person claims that's too low, then low would change to 11. That's a cheat detection because low is bigger than high. If the person says 10 is too high, that would change high to 9, and that would fire the cheat detection because low is bigger than high. So that's how you kind of sandwich them down to a little infinitesimal range of truth. Alright, so let's talk about fgets and strings and string compare in this business of asking them to enter a number, to enter a high, low, or correct. So your get answer function. And so there's a lot of ways to do this, but I don't want to make it more complex. So let's just play with some junk code. And we're going to want string.h because we're gonna do some string manipulation. So we'll prompt the user. This is not PA3. This is just sample code, right? We'll prompt the user, and let's just use fgets. All right. We don't really need to use scanf here, right? Scanf is great when we're getting input from the user that looks like a bunch of integers, right? Or floating points or things like that, and we need to do some conversion. If the person types 123, how do we change that to the integer 123? That's what scanf will do, right? That does all the hard work of building up, weighted positional notation and so on. But if we're just trying to pick off a first character, we don't need to deal with scanf, right? So let's just start printing some things. Let's just look at temp bracket 0. And what I'm going to do is I'm going to print out first character is, and then inside these angle brackets I'm going to print out temp bracket 0. And so if I say, H, it tells me temp bracket, first character is H. If I do an L, the first character is L. If I do a C, the first character is C. If I say, 1, 2, 3, the first character is 1. If I just hit an enter, the first character is a new line. And we can tell that because it printed the angle bracket, and then the closing angle bracket came down in the next line. So if our goal is to figure out whether they typed an H, an L, or a C, we have a few options. So one option is to just look at the first character. So see if whatever you call the input, that's equal to, you know, H, L, or C. And in that case, the second character is going to be a new line. Right? Because the thing about fgets is it always adds a new line to the end of the input, assuming it fits inside the string. So let's just continue this. And let's say second character is, and let's print out temp bracket 1. So now if I type exactly an H, it'll tell me the first character is H, the second character is a new line. If I type hi, first character is H, the second character is I. If I just hit enter, the first character is my new line, the second character is actually the null terminator, which just shows up as not printing. So one option is to do a pair of if statements. See if temp bracket 0 is either character H, L, or C, and temp bracket 1 is the new line. A second option is to see if temp 0 is either an H or an L or a C, and the entire string temp consists of 2 characters. And if it does, then that second character has to be the new line, and we know they typed in exactly an H, an L, or a C. The third option, which is the one I'm going to go with right here, is to use string compare. And if I compare my string to the string H followed by a new line, that will match if that's exactly what they typed in, just an H, and they hit the enter key right after. And string compare is a built-in function. It's in the strings.h include file, the prototype for it. And string compare compares 2 strings and tells you basically which one is bigger than the other. So it alphabetizes, and if this string comes before that one, it'll return a negative number. If this string comes after that, it'll return a positive. If they're equal to each other, it'll return 0. So if string compare of that is equal to 0, the person typed an H. So you can do either of those, but let's just use string compare. So if string compare temp to h\n equals 0, I'll print a message saying the user entered H. Otherwise, if they typed an L or a C, I'll respond accordingly. I'll print an error message. So if I type an H, user typed H. If I type an L, they typed an L. If I type a C, they typed a C. If I type hi, it says nope. If I type LL, if I type space H, if I type just space H, that's an error. If I just hit enter, that's an error, right? If I hit C followed by a space, that's an error. So this will pick up exactly a C, an H, or an L. So that's one way to do it. Like I say, there's a multitude of ways to do it, but the basic goal is to understand that when you do fgets, if they type a single letter, then this string will contain 2 characters. The letter they typed followed by a new line. And so string compare is just looking to see if what they typed was an H followed by a new line, for example.
So I kind of have a question about that.
Mm-hmm.
So you mentioned if it's positive, then the character in the first character of temp is higher. Is it higher? Is like a higher character value, or is it? Can you explain what is higher?
So it compares ASCII code basically. So if you check the manual page for string compare, compares 2 strings, returns an integer less than, equal, or greater than 0. If S1 is found to be less than, to match, or be greater than S2. And greater than means looking at the ASCII codes character by character. So if I do a string compare on, you know, cat and dog, this would be less than 0. If I do, you know, elephant and dog, this would be greater than 0. If I do a lowercase cat and an uppercase dog, this would be greater than 0 because this has ASCII code, you know, 98 or something like that, and this has ASCII code 69 or something like that. So it's a straight comparison of the ASCII coding of each character, and it's alphabetizing. Right, so if I compare these, this will be something less than 0 because, you know, the A's match, but this B comes before the C. And we'll use this probably in a later assignment when we start doing some alphabetizing and building dictionaries. Yeah, another question.
Can't you just use scanf with %C, %S?
You can. What would you do with the result?
What do you mean?
Well, what are you going to do after you scan F?
Or scanf, sorry, I mean.
So you're going to do an scanf on temp.
Check to make sure that its result equals 1.
So you're going to do a %C, %S.
Correct.
And then some answer. So let's try that.
That's what I did. Although I used the extra method with the.
All right, so let's scan F temp. So %C, %S, and then we'll do an answer and an extra. So we'll say got a single character. Alright, so if I type in A, it says got a single character. If I type in ABC, it did not see that as a single character, so that's good. But if I do an A followed by a bunch of spaces, it'll say got a single character. And the reason for that is scanf kind of ignores spaces. So
the point stock on the assignment if you have spaces after it?
Yeah, it's got to be just an H, an L, or a C. I mean, it would be a goofy user who would type an H followed by spaces, but I might be a goofy user. So scanf is really good for, like I say, parsing integers, floats, things like that. But it does ignore white space in certain cases. And if I try to use a %C right here, right, that will always match because it will pick up the new line as a %C. And then I could check answer and extra, but this would really just be temp bracket 0 and this would just be temp bracket 1, so we don't need to deal with the scanf at all. So if you're using scanf and you want to deal with the extra space question, just throw in a string length check, right? So if return equals 1 and 2 equals string length of temp, then we can say we got a single character. We gotta have a typo. So there's a single character, there's not two single characters, and there's a character with some spaces, and it still knows it's not a single character. So if you already did this with scanf, you can just add in one more check. Just make sure string length is equal to 2, and that should work fine.
Sweet, thank you.
Yeah. All right, other questions?
Wait, which string would you check? Do you check extra?
I was just checking the original string temp.
Ah, okay. Cool, thanks.
Yeah. All right, good on that.
Could you go over what main.h is, or what its primary difference is from .c files, and also how to link like the different the files like the predict.c, the intro.c, etc. Those files to the main.c file.
Yeah, absolutely. So this really brings us to our next topic, which is Makefiles, and that's what this is all about. So let's hop into our 224 directory, and let's mess around with this. So void main. So let's call our intro integer x equals get answer and display x. All right. So here's just a junk file, right? It's just a sample main program that's going to do three things: call an intro function to do something, call a get answer that will, you know, return an integer, and then call a display function that'll display something. All right. So so let's go ahead and write these bogus functions. So intro.c will be void intro and we'll just print a hello message. GetAnswer.c will be let's just return a number. And then let's make our bogus display function. So this is void display, takes an integer. All right, so it doesn't do anything useful, right? We're just trying to make a main program that calls some other functions with each of those functions inside its own .c file, and we're going to look at how to compile them, how to link them. We're going to make a .h file, and then we're going to use a Makefile to packetize all of this into something that someone can easily do to build this program. So that's our basic setup, right? And we can be sort of heavy-handed and just say, you know, compile all my .c files into a main. We'll generate, you know, some warnings here because I didn't prototype anything, I didn't include stuff and so on. But you know, this should basically work. So it did my intro, and then my get answer returned a 17 and display the number 17. All right. So how do we clean this up? One thing we need to do is include standard io.h and then put in our function prototypes. So intro doesn't take any types. Get answer returns an int but doesn't take any arguments, and display takes an integer and doesn't return anything. And this will get rid of most of our errors, but you know, display is still I misspelled standard io, I think. Display is still using printf, intro is using printf, and those don't have standard io.h. So let's put those in. So we'll put standard io.h in there, and I'll put it in there just for good measure, and I'll put it in there, and it should already be in our main. So now if I compile this, everything is nice and clean, and when I run it, you know, it works the way we want. All right. So that's breaking our file into pieces, right?
Question?
Yeah.
Could you put the include standard io.h in the main.h file?
So yeah, so we're about to do a main.h. We don't have a main.h yet, right? But that's our next step. So if we look at our main program, right, it's got these function prototypes in here. It's got an include of standard io.h. It could be that some of our other functions also use intro or get answer or display or something like that. And it's possible that, you know, we would have to put these function prototypes into you know, other pieces of code. So what we can do is we can take all of this stuff and we can put it in a separate file, which I'm going to call main.h. And then instead of doing any of this, I'm going to say include quote main.h. Alright, what that's going to do when I compile main.c, the compiler is going to get to this line, it's going to say, oh, include main.h. It's going to take these 4 lines from main.h and it's going to put them right here. Alright, so that it says if I had typed those 4 lines at this point in my main.c file. And so I can do this in my other files. Alright, so now all of my files include this main.h, and if I try to compile, everything still compiles fine and it still runs. The advantage of doing this, though, is that suppose I have, you know, 15 functions prototyped somewhere, and I want to change the prototype on one. I want to change my display function to take a double instead of an int. Instead of going through all of my .c files and looking for everywhere that I prototype that function, all I have to do is go into my main.h and just change this one line right here. And since every file is including this main.h, every file would see that new prototype for my display function. So things that are code that is shared in common like this, function prototypes, structures if you're using structures, some include files, macro definitions, those things can go in a .h file. For example, I might put in here define magic to be, you know, 42. And now in my get answer function, I could just return magic. Now if I compile everything up and I run main, it displays the number 42. If I wanted to change that magic number to be something different, like, you know, 119, I can just change it in the .h file, recompile, and now, you know, it's using that new magic number. So the .h file is a nice place to put in things that are going to be used by potentially more than one file in your program. Now, if you've got something that's only going to be used in one place, you can just put it inside the .c file. If I know that there's a function prototype that's only being used inside, you know, getAnswer.c, I could just, you know, put that prototype in the top of getAnswer.c. But there's no harm in prototyping a function that you don't use. And so, for example, when I compile my display.c, right, up here in the beginning where it says include main.h, it's basically, you know, pretending that all of these lines are inside my display.c file. I don't use the intro function in here, but it does no harm to declare it. I don't use the magic number in here, but it makes no harm to include that and define it. So .h files are things that you might potentially put into multiple .c files. But we don't put code in here. we don't write a function and put it in here. We put in prototypes for functions, but if you want to write a function, you put that in a .c file. Does that make sense?
Yeah.
All right, so let's talk about compiling things in pieces. So I've got my 1, 2, 3, 4.c files, I've got a .h file, and I've got my executable. And I've been compiling by just saying, you know, gcc-o main star.c. So every time I do this, it compiles display.c, getanswer.c, intro.c, and main.c. And if you have, you know, 1,000 .c files and you compile all of them every time that you want to rebuild your executable, that's a lot of compilation. And so we can be more nuanced in how we build our executable by doing partial compilation. Let's see, would it make sense to have multiple header files? Sometimes, which is why you know, there's a standard io.h, a math.h, a standard lib.h. Sometimes if you have a very big project, there may be, you know, some include files that make sense in this part of your code and some that make sense in that part of your code, and so you could have multiple .h files. Probably won't have to do that for what we're doing, and it's certainly less prone to error if you have a single one, but definitely in larger projects you would have multiple includes. All right, so remember when we talked about some of this stuff earlier, I drew a picture of file 1.c, file 2.c, file 3.c. And if we just say GCC, you know, file 1.c, file 2.c, file 3.c, we end up with this magic executable program, main. But in the process of compilation, there's a series of steps that happen. Your C code is effectively converted to assembly. The assembly code is converted to machine code, binary code, and then that binary code is linked with things like printf and so on to create an executable. So what we can do is we can turn each of these into an object file, which has a .o extension. And we do that by saying gcc-c. And the C says, compile the file, but don't link it into an executable. And then we can take these 3.o files and combine them into our actual executable. And so let's do that by hand, and then we'll talk about how to avoid doing it by hand. So if I say gcc-c display.c, now I have a display.o. I can do getanswer.c, intro.c, and main.c. And now I have a .o file corresponding to each of my source.c files. And let me get rid of my executable. Now if I want to build my executable, I can do the following. I can link my .o files. And there's my executable program. The advantage of doing this is that it's very efficient. It's way more efficient than compiling each of my .c files. So let's suppose I want to change my intro to say, hello Nick. All right, if I want to rebuild my executable, I only have to do two things. I have to recompile that intro.c into a new object, and then I relink my objects into my main program. And then it says, hello Nick. So the whole game we're playing here is, instead of just saying gcc star.c, which would have recompile display and get answer and main, right, I only compiled one .c file, intro.c. That's the file that I just changed. That gave me a new intro.o, and I linked that with the existing display, get answer, and main.o to make my new executable. And it's an efficiency thing, basically. Still with me?
What are so the object files contain what again?
Those are the compiled .c files. So for example, intro.o is machine code, right? We can't read it, the machine can, but it's not an executable program, right? It's not something that you can run. It's incomplete. It doesn't include, you know, what it needs to call the printf function, for example. But it can be turned into an executable by using GCC and say, you know, take intro.o and turn it into an executable main. So it's this intermediate step between the source file .c and the executable file. And so these are called object modules. These are source files.
So if you didn't pass -c into GCC, it wouldn't have created the intermediate object file?
Right, if I didn't do -c, if I just do gcc intro.c, GCC will compile it into an object file and then try to turn it into an executable file, and it's going to fail miserably because there's no main program inside intro.c. And so it's saying undefined reference to main. So to make the executable, I need to compile all of the different pieces and then link them together. And I can do that by just saying GCC each of these, but that's recompiling code that I may not have changed and don't need to recompile. So we do the first part of the compilation process. We get these objects, and then we take those and we link them together to make our executable program.
So if it's a big program with like lots of files, is there any way to streamline like having to type in all those different files and link them together?
Yep.
Or is it just something you can do?
So that's what a Makefile is going to do. So a Makefile will let us write a description of how to do all of this stuff. And it will vary from program to program. But we'll create this recipe or this set of instructions for how to build an executable, and then we'll use a program called make to actually go ahead and you know, compile these and link them and so on and so forth. And this is important because, for example, suppose I wanted to change my magic number, right? So in my .h file I have this magic number 119. Suppose I want to change that to, you know, 10,000, right? What do I have to recompile to make this work? I don't know. I got to figure out who's using that magic number. Well, I remember it's the display function, right? Because we just wrote this. But if I had downloaded this from the web and I wanted to change the value of some parameter, how do I know which C files have to be recompiled? So this is part of what we can put inside a Makefile. So a Makefile is just a plain text file. And it begins, it's basically a pair of lines. So we'll have one line that lists what we call a target, a thing that we're trying to build, followed by a colon, followed by dependencies. Things that need to exist and be up to date in order to build this target. And then our second line will begin with a tab, and it has to be a tab, it cannot be spaces. And this will be followed by a command which will build that target. And we'll just keep repeating this over and over. Alright, hard to explain, easier to see in practice. So what's the main thing we want to build here? It's our program called main. And in order to build main, we need the following pieces to exist in our directory and to be up to date. We need to have main.o, intro.o, display.o, and getAnswer.o. Alright, those are the 4 object files that have to exist and be up to date in order to build our main program. And if those exist, so I'm going to put in a tab and I'm going to type in my gcc-o main and my whole compile line. So this is listing the dependencies, the things on which main depends, right? The things that need to be up to date in order to do this, which will build our program called main. And we're just going to make a bunch of pairs of these pairs of lines. So, for example, main.o depends on main.c, and it also depends on the header file. And assuming that main.c and the header file are up to date, we can now say gcc-c main.c, and that will build main.o. And so we're going to do this for each of our functions. Alright, so what does this whole file mean here? Basically it says, hey, you know, the first thing on here is main. That's the first target. So if I just use the command make, it's going to look for a file in my directory called Makefile. And when it finds that, it will look at the first line and say, oh, this is a recipe for how to create this thing called main. And it will say, what do I need to have in order to create main? I need to have this, and this, and this, and this. They need to be in my directory, and they need to be up to date. And if they are, then I can go ahead and I can execute this command. That will create, presumably, my main executable, and I'm done. But suppose there is no main.o in my current directory. It will search through for a target main.o, and it'll find it right here on this second set of lines. And that'll say, hey, to build main.o, I need the following. I need main.c and I need main.h. And if it finds both of those, it'll execute this command, and that creates a main.o. And then it looks for intro.o, and maybe it finds that, and it looks for display.o, it finds that. It looks for getAnswer.o, maybe it doesn't have a getAnswer.o. It will look for a target, getAnswer.o, find it right here, and say, hey, I need getAnswer.c, main.h. If those exist and are up to date, it will go ahead and compile getAnswer.c to create getAnswer.o. Once it's done all of that, it will say, hey, guess what? All of these dependencies are satisfied. These all exist. They're all up to date. Now I can go ahead and do this command, and that should build my executable main. So if we do that, let me remove main and let me remove my .o files. So all I've got is my .c files, my .h file, and my make file. How do I make my executable program? 4-letter command make. And you can see what make did. It did each of these compilations, and then it created my executable main, and there's my main. And if I say make again, it'll say main is up to date. Alright, let me change my intro.c to say hello again. How do I rebuild my executable? Just say make. And make knows, hey, I've got to recompile intro.c. It did that, and then it did my gcc-o. And now my main program has been updated. And if I say make again, it's up to date. Go ahead.
For the make file, do you want it to run the program after when you run make, or?
No, make usually is just for creating the executable. Because you're only going to run it once, which is to build, in this case, the file main. And then you could run it by, saying main. But it's really just used to compile and link your code together.
Can you show me the make file again?
make sure these are tabs. If these are spaces, it will not work. And I think the error message won't give you much help. So make sure these lines that contain the commands start with tabs. And this is using timestamps. Sorry?
Should I set my tab to 4 spaces? Does that matter?
It's got to be a tab
Yes, it
character.
does.
If your editor is replacing tabs with spaces, it won't work.
Well, it doesn't replace it. It set the distance to be 4 spaces.
That should be
If it's a
fine.
Space button, it'll take them all out. But
Yeah, as long as it's long as it's a control I, it should be fine. Like that.
If you're doing this in VS Code, make sure you set it to insert tabs instead of spaces.
Yeah. So this is using timestamps, right? So if I edit intro.c, what happens? To build main, it's got to use intro.o. It's going to look at intro.o and say this depends on intro.c and main.h. It'll look at the timestamps and it'll say intro.o was created at 10:30. Intro.c was updated at 10:38. That's newer than intro.o, so it knows it has to rebuild this. That's why it did that GCC command. And then after it did that, it looked at main and it said, the timestamp on main was 10:31. The timestamp on intro.o is 10:39. That's newer, so it's got to rebuild main. So that's why it did this GCC command. And then if you say make, everything's up to date. Now if I edit my include file to change this, back to 42, and I say make, well, I told it that every file depends on main.h, and so it recompiled all of my files. And now my main is using that new value. We can also do other things in here. So I can make a bogus target called clean, which has no dependencies. And I can say rm display.o, intro.o, getAnswer.o, main.o, and main. Well, I'm not compiling anything here, but make doesn't care. All that make knows is that if I say I want to build something called clean, there's no dependencies that have to be satisfied, and here's the command that it should use. So what does that do for me? Well, here's what my directory looks like right now. If I say make clean, it will look through the recipe for a target clean. It will find that new line I just added. It will execute the command on the following line, which says remove these .o files on this main file. And so now if I do an ls, I'm back to a clean directory with just my source files and my make file and my include file. And now if I say make, it'll recompile everything. So why do you want this? For example, suppose you copy this code to another machine, like a Raspberry Pi. It's a different architecture. You can't just run your main program. But if I copy this verbatim onto a Raspberry Pi and I say make, it'll say everything's up to date. So if you want to force it to recompile everything, now I can say make clean. That gets rid of all the stuff that was compiled, and then make forces it to recompile everything. And so traditionally we put a clean target in here that removes the objects and the executables. And the PA3 write-up mentions including a clean option in here. Alright, I'll push this over to the shared code area on 224. I'll put it in a directory called make stuff or something like that. And I'll have all of this stuff in there so you can go back and refer to that for kicks. All right, we are out of time, so have a good one. Send me one attendance ping on your way out, and I'll see you tomorrow.
Can you quickly show me the paper for how to make a Makefile? Yes, like we put on paper. I'm taking notes.
Let me see. This one?
Yeah, so target, then its dependencies like what it's searching for.
That's the list of files that it needs to build that target.
Right, hold on, I'm just taking notes.
And then for between you remove all the object files, right?
Remove the objects and the executable.
Okay. Yeah.
Alright, have a good day.
All right, thanks. Have a good one.